Hi, I'm Steve Morris, Vice President of Residential Sales for Dynamic Air Quality Solutions. I know many of you have been through our technical and communication IAQ training, but we really never have the time to break down the products piece by piece and the technical details. So these next few videos are going to be all about that. We're going to take each product, break it down technically so you have a really good understanding of how it works. So sit back, relax, and get ready to learn. I'd like to introduce you to Gary Narp. He's our in-house UV expert. Between Gary and I, we've got over 45 years experience in ultraviolet energy. As a matter of fact, we were on the first design team in the early 90s that designed the first ultraviolet energy lights for residential applications. I'd like to say we invented it, but we didn't. UV has been used commercially since the 1930s, so it's not a new technology, but it is new residentially. So Gary's going to help us take these products and break them down technically. So welcome, Gary.
Yeah, thanks for having me, Steve.
Okay, Gary, let's start with the 401 and 403 models. 401 first is our germicidal unit. If you can kind of go through the details starting with the lamp on that one, that'd be great.
Yeah, this is a rather unique product we have compared to competitors, Steve. We have a 180 microwatt lamp, which is a twin tube lamp, so it's really two 16-inch lamps side by side. So in reality, it's a 32-inch lamp. But since
and that's how we get, the longer the arc travels, the higher our microwatts.
The higher the microwatts, and ducts aren't that deep, so the only way to get this microwatts is to make it a double tube and bring it back.
Hence the H shape, that's the little bridge there. So that arc goes through that bridge and comes back down, right?
Exactly. Also, to get the life out of the lamp, there's a coating in the lamp, and the coating slows down what they call solarizing. And solarizing is a process where the reaction going on inside the lamp with the gases actually pits the inside of the glass, and as that glass isn't smooth anymore, the UVC light can't get out. So the lamp indeed is lit, but the microwatts of UV coming out of it aren't the same as when the lamp was new.
And that's what most people don't understand. They say that the lamp is still lit, why do I have to change it?
Absolutely. And a lot of competitors will have a one-year lamp, and if you don't put that coating in it, actually within a year you'll lose as much as 30% of the output of the lamp. So typically they have 55 microwatt lamps, which are really only good for surface irradiation. If they lose 30% of that, even at the end of the first year, you're going to start getting growth on coils and what have you.
Because we're going for airborne sterilization and surface kill.
Right, with 180 microwatts, and you have to really look at this as, you know, the lamp's in the duct and we're getting upstream and downstream irradiation. And the reality of it is, let's just say hypothetically we have an 8-foot duct, 4 feet before the lamp and 4 feet beyond the lamp we'll call our deactivation zone. So as these microorganisms are flowing through the duct and heading for the lamp, there's really a lot of time. You know, it's not a matter of
8 foot of area.
8 foot of area. It's not like just the instant it goes past the lamp it can kill it. It's affecting it as it's approaching it and as it's going beyond it.
So we get a lot more dwell time that way.
A lot of dwell time, and that's what's critical about having the lamp the correct way in the duct and getting that upstream and downstream irradiation. Where you know, we'll see some units that have like a screen around the lamp. That's blocking the UV rays. Now you lost all that upstream and downstream irradiation. So,
well, they claim a lot of things are happening off the screen. That's for another subject.
That's another whole thing. Another interesting thing about this unit, this is not an oxidizing unit, so it can be wired and left on all the time. Or for energy efficiency, this can be cycled with the system. And that's because the ballast we're using in here is a program start ballast. So it has a precise amount of time that it preheats the filaments before lighting the lamp. So this unit would actually be capable of cycling the lamp on and off well over 200,000 cycles in the life of a lamp.
And we have 32,000 cycles per year if you add all the seasons together. So you can get 6 months or 6 years of cycling out of this.
6 years of cycling out of it. We recommend replacing the lamp every 2 years just because
the
solarizing.
Right.
But yeah, the life of the lamp's that long, and that's great for warranties. You know, we don't see lamps burning out in 2 or 3 years. They keep lighting, but then you have to educate your homeowner, well, the microwatts are decreasing. And you know, if I knew how to do it and there was an easy way, at the end of 2 years, the lamps would just quit working and we could, you know, replace them because they're burnt out. But that isn't the way it works. They really light a long time. This unit is also multi-voltage, so this will work from 115 up to 277 volts, and it's auto sensing.
So it knows what it's wired into. You don't have to flip a switch or anything.
Right, whatever you put into it, it's going to sense that and put that correct voltage to the lamp. It's also a constant current ballast, meaning these lamps operate on 425 milliamps. So if we want to use the 16-inch lamp, it'll light that correctly at 180 microwatts. If we need the shorter lamp because the duct isn't deep enough, which is going to be a 140 microwatt lamp at 12 inches, it will light that lamp correctly. And I believe we even have a 7-inch lamp.
Yeah, for some applications.
And that could, you know, be put in here and it would light that perfectly. And that's a really cool thing with new ballast technology, because in the old days we would have had to have a different ballast for every different length lamp. So it really makes it versatile, and it makes it easier for the contractors, because if you have, you know, a unit on the truck and you go to the job site and, you know, you thought you were going to put in a 16-inch lamp and you get looking at the duct and it won't fit. And if you had a 12-inch replacement lamp on the truck, you could just swap it and put in the 12-inch lamp, and it works perfectly. Yeah. So it really makes it versatile for the installer. You run into a goofy situation, you're not running back to the shop. Very energy efficient because we can cycle it, and even if you're going to put this model over the coil and have coil irradiation in the south, because of the 180 microwatts, this does not need to be on 24/7. So you could still, if you chose, wire it with the blower, and it's going to be much more energy efficient than competing products. So
yeah, most of the coil irradiation products out there, they're 45 microwatts, which is plenty if you're on all the time to get the job done.
Right.
But you're still not getting the airborne sterilization.
It's going to do literally nothing for microorganisms that are passing through. And it, you know, well, you guys have seen it too. You can find a lamp that's a year old in the 45 microwatt, and I've actually seen lamps where there's mold growing on the tube itself.
Yeah,
they
which is supposed to be killing.
Supposed to be killing. So microwatts are the big thing. It's you know, same with heating or cooling. You need so many BTUs to get it done. With UV, we need so many microwatts to have enough energy to actually.
Yeah. Well, the guys that have been through our training, we always use the analogy: if I lit a match, would it be hot? And everybody says, well, of course it's hot. I said, well, can you heat a house with it? And the answer is no, it's not enough heat. So one match is 1 BTU. It takes tens of thousands of BTUs to heat and cool a home. And it's the same thing with ultraviolet energy. You can use, there's 28 microwatt lamps out there. They create the UVC energy, but they don't create enough power to get the job done. So let's jump to the 403H. This is a dual system. It does oxidation and ultraviolet C energy for germicidal.
Yeah, so we have all the same features on the germicidal lamp, the intensity, what have you. This one, because it oxidizes, will remove cooking odors, pet odors.
Organic.
Anything organic.
Yeah.
Musty smells. So I almost use the word instant gratification. If you put the germicidal unit in a system, you're telling the homeowner that, you know, this is going to either kill or deactivate microorganisms as they flow through the system.
So viruses, bacteria, less colds and flus and stuff like that, allergies, allergic reactions.
Yep, exactly. But they can't tell you did anything. When they come home, there's nothing that you can perceive with your senses. You put the oxidizing unit in, and the home smells fresher. The air smells fresher. It's nicer to live in the house. And
I tell people they're smelling the lack of smell.
Exactly. You can tell something happens, so the perceived value of the oxidating units always makes a happier customer than something that they're hoping it does something because they can't sense it. Now, when we have an oxidizing unit, every house isn't the same. If you have pets, it's going to take a little bit more oxidant. If you do a lot of cooking or smokers, square footage is different, hardwood floors, carpeting. So that has to be adjustable, and the adjustment on this is something we're able to patent, so that makes this product quite unique to us.
So if you turn it this way, go ahead and adjust that. What it's doing is that it's allowing more or less of the UVV rays coming into the ductwork. So as the oxygen is going by, it's converting that into an oxidizing agent that'll allow us to get the organic odors out of the air.
Yeah, and it's actually important that we did this way. At one time, we actually tried dimming the lamp. And the thing is, these lamps, they're real touchy on the proper voltage. The films need to be preheated well. You're going to get the most life out of the lamp running it at 100% and at the correct voltages and efficiencies. So by doing this and using a shutter to change the amount of light in, but allowing the lamp to always run at 100% efficiency, you're going to get the maximum life out of the lamp, and we're going to have less problems. So this is, you know, mechanically dampering that light is really the way to do it, to electrically have a product that's going to last a long time. We estimate the life of this ballast in our applications to be 30 years.
Okay. And there's a potted ballast as well.
This is a potted ballast, which helps it dissipate heat, and that's part of the reason, you know, that we get such a long life out of it. If you feel one of these units when it's on, it's not even lukewarm to the touch, so there's very little heat generated by the ballast. The ballast technically is actually an Energy Star ballast, and it's very efficient. Energy Star does not rate germicidal lamps, so we're not allowed to put the Energy Star seal on it because it's a specialty lamp, and they don't yet have a rating for it. But the ballast is used in other industrial lighting where they're allowed to use the Energy Star seal on it, so it's very, very energy efficient.
Okay, great. So we got the adjustable oxidizing system. Same UV light as we're using in the 401, so we're getting the same germicidal sterilization and kill. And its kill area or its sterilization area is about 3 to 4 feet away from the lamp, right?
Right on either side of the lamp. And
so that gives us 8 feet if it's in the ductwork.
8 feet, and really the right word is a deactivation area. Whether we kill a bacteria, virus, or deactivate it, we don't care. If you deactivate it, you upset the DNA in the microorganism, it can no longer reproduce. If you breathe a cold germ that can't make more cold germs,
it won't fill up your body.
It does nothing. So
okay, great.
It isn't critical to kill it, but it's nice to make it where it's harmless.
Okay, appreciate that, Gary.
All right, thanks.